Welcome back. In this lesson, we are going to learn about relational entities such as catalog, schema, tables, and views. The Databricks Lakehouse organizes data stored with Delta Lake in cloud object storage with familiar relations like database, tables, and views. This model combines many of the benefits of the enterprise data warehouse with the scalability and flexibility of a data lake. Using this relationship of the entities, we are able to use the same T-SQL type 3-level system to access database objects, which is similar to the relational databases such as Microsoft SQL, Oracle, or PostgreSQL. Let's begin with the meta store. The meta store contains all of the metadata that defines data objects in the lakehouse. Example, Unity Catalog Meta Store. A single meta store can be used across multiple workspaces. Unity Catalog provides centralized access control, auditing, lineage, and data discovery capabilities. You create Unity Catalog meta stores at the Databricks account level, and a single meta store can be used across multiple workspaces. Next comes the catalog. Catalog is a grouping of the databases. It is the highest abstraction in the Databricks Lakehouse relational model. Every database will be associated with a catalog. Catalog exists as objects within a meta store. Next is schema or database. This is grouping of the objects, tables, views or functions. A database is a collection of data objects such as tables or views and functions. In Databricks, the term schema and database are used interchangeably, whereas in many relational systems, a database is a collection of schemas. Next comes the tables. A Databricks tables is a collection of structured data. It is a collection of rows and columns stored as data files in a object storage. A view. What is a view? A view stores the text for a query typically against one or more data sources or tables in a meta store. In Databricks, a view is equivalent to a Spark data frame persisted as an object in a database. This diagram shows the hierarchy of the relational entities. To create a catalog, we start with the command create catalog and catalog name, such as if we want to create a catalog for, let's say, with the name of sales team underscore catalog, so the command will be create catalog and the catalog name. To create a catalog, we should have the appropriate permissions, plus the Unity catalog should be enabled on the cluster. So this command will be used to create the catalog. Next is to display the available catalogs. So the command is show catalogs. When I run this command, it will show me the available catalogs. The Spark catalog is the default catalog. The next command is the database command. I will create a new database. Let's say create database and the database name. I will execute this command. The command has executed successfully and the database has been created. I can also say create schema. As mentioned earlier, database and schema are used interchangeably within Databricks. So I will execute this as well, and I will show you that database has been created with the name of database 001. Similarly, schema 001 has been created and both are within the same hierarchy. I will go to the data tab. Within the Hive meta store, I can see two databases. One is the default database that was already there. We have created two new databases, database 001 or two new schemas and schema 001. They do not have any object within them as of now. I can also use the command show databases to display all the databases that are available. We have these three databases. The next is show schemas, again because schemas and databases are same in Databricks, so the output is still the same. The next command is create a table. The command to create a table is create or replace table and table name. So here we are saying create or replace table, the schema name and the table name. So this table will be created within this schema or within this database. And what is the schema of the table? Table has three columns, column 001 and data type is integer. Similarly, column second is a string and column 003 is again a string. I will execute this command. The command has executed. Now I will insert two records within the table. So this is the first record and the second record. The two records have been executed, inserted successfully. I will display the content of the table. Select star from the database or the schema name dot the table name. So we get the same data records that we inserted into the table. I can also use a 3-tier name query to query the table, which is the catalog name, Spark catalog, then the schema name and the database name. This should also give me the same result. Here it is. Then the next is to view the properties of the table. I can use the command describe table or describe table extended. Describe table provides me the schema, output schema of the table, whereas describe table extended provides me schema and many more detailed information. So if I execute describe table extended and the table name, it gives me the schema of the table plus more detailed information like what is the catalog name, what is the database and the table name, when was this created, plus it will also give me the location and the type of the table. So this is a managed table managed by Databricks and the location of this table is within this DBFS location. We can also validate this table in the Hive Meta Store. So this is our database 001. I will refresh and we can see the table does exist. In this command we have the schema name and the table because when we created this table we specified that create or replace table within this schema. So we can even create a table without specifying any database or schema. In that case, the table will be created in the default database. Here is the command to create the table. This time we are not specifying any database or schema name. When we execute this query, the table will be created but within the default database. So the command has executed successfully. I will refresh this database and yes, we can see the table has been created. We can use the command show tables which will display the tables in the default database. This is the table 002 that we recently created. If we want to see the tables in a different database other than default one, we need to specify the name of the database such as show tables in database 001. This will display the table that exists in database 001 such as table 001. I will execute this and yes, we have the right output. Next is creating a view. A view stores the text for a query, typically against one or more data sources or tables in the meta store. So here is the command to create a view. Create view, the database name or the schema name, and the view name. So we are creating a view within database 001. What is the definition of the view? It is select star from this table, database 001 dot table 001, where column is this. I can execute this query separately to show you the output. So this query returns this record. I can now create a view so that this query will be recorded, will be saved within this view definition. Let us query this view. I will say select star from database dot view name. And yes, we can see the output. So this was about the high level information of the view. Please note that if we do not specify the database name here, the view will be created by default in the default schema or the default database. So here we have specified the name of the database or the schema, so the view will be created under this database. So you can see the view has been created under database 001. Thank you.